So what's up, people? I believe everybody is doing great, nice, and absolutely fine. So hi, this is me, Yawar Manzoor, and I welcome you to JEE English Unacademy. If you haven't subscribed yet, just hit the subscribe button as soon as possible, okay? And I just want to know in the live chat if we are live right now or not, okay? And in this one, we will be talking about that's nothing but perpendicular axis theorem and parallel axis theorem, okay? So that's what we're gonna be talking about today. And people, most importantly, I just want to tell you one thing over here that we'll see the concept proof and one or two questions. I'm planning to basically get the problem session on this one, okay, separately. So I'll be basically coming up with that very soon. And before that, I suggest you to hit the subscribe button as soon as possible, okay? Now, people, over here that you can definitely read it out from the screen. My name is Yawar Manzoor and I'm a JEE physics expert. And this is a piece of information about me. You can definitely read it out, okay? And next thing over here is that if you people want to join our Telegram channel, this is the link over here, understand? So link is in the description as well. Join it as soon as possible because whatever the important stuff we have, we put up in the Telegram channel only, okay? So you can join over there. You can join us for sure inside our Telegram channel as well, okay? Whatever the important stuff we have, whatever the news we have, the class notes, we send it in the Telegram channel as well, okay? So what's up, people? Yes, hello, hi. And apart from that, you might have recently seen that how good results Unacademy has produced in JEE Advanced 2021 as well as in Mains 2021. Like AIR1 was from Unacademy, okay? And AIR 87 was from Unacademy, 18 was from Unacademy, okay? So many double-digit ranks we have produced in JEE Advanced 2021 as well, okay? Now, if you people want to basically fall in that particular category, you are supposed to join and this Iconic as well, understand? So join this plus and Iconic as well, understand? So now the point is exactly love from Jomu. Thanks, man. So now the point exactly is if you join this plus subscription, what are the benefits that you can exactly get? You'll be getting live classes every single day, okay? There are tons and tons of live classes in the particular category that you can exactly watch, okay? So you can watch that. And weekly tests. Weekly tests are highly mandatory from advanced point of view I'm talking about, okay? So whatever the stuff you have studied for the entire week, afterwards you need to give the weekly test, okay? That's mandatory, okay? That's mandatory, okay? And the next thing is structured courses. The courses which have been designed by the top educators of the country will be given to you, understand? These courses are highly mandatory, designed by the top experts who have got 20 to 30 years of experience will be given to you, and unlimited access, okay? This unlimited access is basically that you can watch anybody's lecture any damn time and you can create your own batch by selecting your personal favorite educators, okay? And in this Iconic subscription, you will be getting personal guidance, okay? Personal guidance is all about the personal mentorship, okay? Whatever the clarifications, whatever the doubts you have, you can ask that personal guide. He will be 24/7 with you. You can ask him whatever it is. And you will be getting the test analysis. Test analysis is what? Once you are done with your mock test, afterwards, you need to analyze your test scores. In what portion you are lagging in what portion you need to work more so that you'll get the better scores in your upcoming time as well. So for that, you have to go for this test analysis, okay? And this is done from our end only. You just don't have to do anything. We'll take care of this one. You just have to focus on your studies only. And experts guidelines, okay? Study material which will be sent to you to your doorstep so that you'll get the bookish feel. You don't have to learn from the PDFs anymore. Study planners as well. Now the point is for how much amount of time you can take this subscription. Hi, what's up, people? Point is exactly for how much amount of time you can take this subscription, okay? Is everybody doing great over here? For how much amount of time you can take this subscription? You can take it for 24 months, 18 months, 12 months, 6 months, 3 months, okay? So these are the benefits that you can exactly get in this plus. Now, if you want the maximum possible discount, 10% additional discount, you can use my code. This is Yawar. You can use this code in order to get the maximum possible discount over there, understand? And most importantly, this no cost EMI is available, okay? No cost EMI. What is this no cost EMI? Means if you don't have to pay this entire amount at once, you can pay it on monthly basis. For that, you just don't have to pay any sort of interest, understand? So that's what we call the no cost EMI in all of these plans. Make sure you use this code over here. And these are the plans for Iconic, understand? No cost EMI over here as well. These are the benefits you get in this Iconic. Keep this thing in your mind. Now, these are actually the batches which we have recently launched on Unacademy. You can definitely check it out. That is this Excel batch, this Droppers batch. This is in English language. The people who are looking for the batches which are completely in English language, so this is for you. Join it as soon as possible, okay? And this has started from yesterday itself. This also has started from yesterday itself. You can join it as well. Now, the people who are looking for starting their preparation for IIT JEE, so this is the counseling session, this is the academic session, this is basically the preparation strategy session for those people. If you people want to join this one, use my code Yawar to enroll in that, understand? Okay, so use my code Yawar to enroll in that. Keep this thing in your mind. You can enroll in these in this one, and this is completely for free, okay? You just don't have to pay anything. This is completely for free. Enroll in this one. Link is in the description below. And this is the T20 test series. You can definitely go for this one. Use my code Yawar to enroll in this one. These are the benefits that you can exactly get. Now, this is what Unacademy has produced in JEE Advance 2021. Okay. This is what that Unacademy has produced in JEE Advance 2021. You can definitely, if you people want to fall in this category, join as soon as possible. Now, there are people who keep asking, is there any way we can learn free on Unacademy? Okay. Okay, just gonna take few seconds. Now, there are people who keep asking, is there any way we can learn free on Unacademy? This is the only way, okay? We call it Mega Combat, okay? We call it Mega Combat. You can go for this. This is a scholarship test that happens on every Sundays, okay? This is 11 a.m., 21 questions, 60 minutes. You can win up to 4 crore plus scholarship. Even if you get the rank from 1 to 3, you'll be getting 1 year IIT JEE subscription. 4 to 10, 75%. 11, 50, 50%. So go for this one as soon as possible. If you people want to take your rank to the next level, learn from the top educators of the country. This is perpendicular axis theorem and parallel axis theorem that we're going to be exactly talking about by today. How many of you people exactly know this? Come on, tell me. So, this is the definition that you can definitely read it out from the screen itself. What is this perpendicular theorem all about? Understand? Forget about this one. Let me just tell you, okay? If I say, for example, I have a disk over here, 2D body over here, disk, whatever it is, fine. So, if this is a disk, for example, over here, understand, 2D body. And if I say, for example, the moment of inertia about this axis, if this is the x-axis, if I say I know the moment of inertia about this axis, that is nothing but I call that Ix, okay? This is the moment of inertia about this axis. And if I say I know the moment of inertia about this axis as well, this is nothing but Iy. This is in 3D. I'm just trying to make this in 3D, understand? And if I ask you to tell me, if you know the moment of inertia about this Iy, if you know the moment of inertia about this Ix, understand? This Ix and this Iy, both are lying in the same plane. This is a disk, okay? Just try to have a look on this one. This is a disk over here. If I say this is Ix, this is Iy. So this Ix, this is the x-axis which is lying on the plane. Understand? This is the plane of the disk, right? This is the disk, and this is, we say this is the plane over here. Understand? Plane of the disk, and this x-axis is lying on the plane of the disk. This y-axis is lying on the plane of the disk. And if I ask you to tell me the moment of inertia about this axis, okay, this is what we call the Iz, or this is the perpendicular axis. We say this axis is perpendicular to the plane of this disk, in which this axis and this axis is exactly lying over here. Okay, can you tell me the moment of inertia about this axis? See, you're saying, sir, I know the moment of inertia about this axis. I know the moment of inertia about this axis. How can I find the moment of inertia about this axis? So perpendicular axis theorem says us that if you know the moment of inertia about an axis which is along the plane of the disk, And if you know the moment of inertia about an axis which is also along the plane of that disk, and you can find the moment of inertia about an axis which is perpendicular to that plane exactly, understand? So over here, keep this thing exactly in your mind, okay? Okay. So keep this thing. Going to hostel, huh? Only for a few days. Okay, so we have exactly over here, so we can say we can find this moment of inertia about this axis IZ. So we say, sir, that is nothing but this IZ is nothing but IX plus this IY exactly. Understand? Now there are some points that you can exactly read it out from the screen itself. That is, the perpendicular axis theorem states that moment of inertia about a planar lamina, okay, that's a 2D body that I told you, about an axis perpendicular to the plane of the lamina is equal to the, about this axis perpendicular to the plane of this lamina. Understand? Moment of inertia about that axis which is perpendicular to the plane of this 2D body, to the sum of moment of inertia is equal to the sum of moment of inertia of the lamina about two axes at right angles to each other, this axis and this axis. Understand? About two axes at right angles to each other, about this axis, about this axis. If you know the moment of inertia about this axis and this axis, this is Ix, this is Iy, you can find, they are at right angles, you can find the moment of inertia about this axis which is perpendicular to this plane. Understand? That is the sum of these two. This Ix plus this Iy will be exactly given to this one. Understand? Everybody understanding this one? Come on, I just need to know in the live chat. If you're getting this one, man, everybody. Hey, Love sir will come, man. He's on leave, that's why. Why every time the people keep asking the same question, when is Love sir coming? He'll come, okay? He's on leave. So, I can definitely say this is nothing but perpendicular axis theorem. Now, there is a question. Let's basically solve a question on this one. So that will give you the exact feel of this one. Understand? If I say, for example, the question is something like this. This is a disk. I'll take a disk only. Understand? This is a disk. And you are supposed to tell me the moment of inertia about this Ix. How much is the moment of inertia about this Ix? Understand? This x-axis. Okay, this is a disk which is rotating about this axis. Okay, this axis. Can you tell me how much is the moment of inertia about this axis? This is a disk. Okay, this is rotating. This is a disk. Okay, this is rotating about this axis, something like this. Can you tell me how much is the moment of inertia about that axis? Okay. Very simple, very basics. Now listen to me very carefully. Yes, it is clear. So now you just tell me one thing. If I take, for example, another axis over here, मैं बोलूंगा this is nothing but Iy, okay? This is Ix and this is Iy. Understand? See, can I say the moment of inertia about this axis will be exactly same as the moment of inertia about this axis? भाई दोनों के about same होगा ना? If I take this as a disk over here, यहाँ पे disk है क्या? If I take this is a disk over here. See, if you take this axis which is something like this, this is x-axis, okay? So can I say disk is basically symmetric from all the sides? इधर से देखो वैसा ही, इधर से देखो वैसा ही. If you look from this side, it is exactly similar. If you look from the other side, यहाँ से if you try to look at this disk from this side, it is exactly similar if you try to look from the other side. But if this is a rectangle, you will say, sir, from this side length is more, from this side breadth is more. Now if you try to look at this disk from all the sides, it will be exactly similar. Okay, we say symmetric. So we say moment of inertia about an axis which is along its plane will be exactly equal to this one. Jitna iske about hoga, itna iske about hoga. Fine. Now you just tell me one thing. We are supposed to find about this one. Can I say about this axis? This is what ICOM or IZ we say over here. Understand? You tell me one thing. We have studied previously, we have derived this relation that if, for example, this is a disk about an axis which is passing through its center of mass, understand, and is perpendicular to this. Can you tell me how much is the moment of inertia? You'll say, sir, moment of inertia about an axis which is passing through its center of mass and is perpendicular to this disk. Previously, we have basically derived that is nothing but, kitna hai wo? That is mr square by 2. If the disk, mass of the disk is m and the radius is basically r. Can you say this Iz in this case is nothing but mr square by 2? ring का क्या होता है? What was the moment of inertia of the ring? That's mr square. Over here, this is a disk, mr square by 2. Now, you tell me one thing. You tell me one thing over here. If you know this one, you'll say, sir, I'll use this one. That is perpendicular axis theorem. That is Iz is equal to, you'll say Ix plus Iy. As you are saying, moment of inertia about this axis will be exactly equal to the moment of inertia about this axis. Disk is symmetric. So this axis is lying in its plane. This axis is also lying in its plane. Understand? So we say this is nothing but Ix plus this Ix twice Ix about this Z. How much that is? Mr square by 2. So this is Mr square by 2 is equal to twice Ix exactly. Twice Ix exactly. Can I say this will come out to be, this is twice Ix. So can I say Ix will be Mr square by 4? Ix will be exactly, that is Mr square by this 4. I can simply say it. So how did I calculate this? By using this perpendicular axis theorem. Understand? So this is how we exactly use it. Very simple concept, not that difficult. Understand? You getting me? We are supposed to find the, now the concept is basically moment of inertia about an axis. Listen to me. This is the definition that I'm making you understand. Moment of inertia about an axis which is perpendicular to the plane of the disk will be equal to the sum of moment of inertia about an axis which is passing, which is lying on the plane. Understand? Which is lying on the plane, plus the moment of inertia about another axis which is also lying in the same plane, such that they are at right angles to each other. Understand? Keep this thing in your mind. This is moment of inertia. Condition is basically this Iz should be perpendicular to the plane of the disk, and this axis should lie in the same plane. Then you can apply the moment of inertia. Then you can apply this perpendicular axis theorem, and this is for 2D bodies. These are the conditions. Use it. Get done with this. Now, let's move on to the proof basically. What is this proof? Okay, let's basically find the proof of this one. Listen to me very carefully. If I say, for everybody understanding, come on, I just need to know in the live chat over here. Okay, everybody. Now, if I say, for example, I'm supposed to find the moment of inertia about this axis. Okay, that is Iz. I'm supposed to prove this moment of inertia perpendicular axis theorem. Iz is equal to Ix plus Iy. Okay, so I say this is nothing but Iz. Fine. Now, I'm taking this axis. This is nothing but, I say this is Ix. Okay. Now, I'm taking this another axis exactly. This is nothing but, for example, I say this is nothing but, hey, this is z-axis, this is x-axis, y-axis, this is z-axis. Don't say, sir, Iz. It's the moment of inertia about this I-axis. That's why I'm writing this. This will confuse you. Bologe, sir ne galat likha. So this is basically x-axis. We say this is y-axis, and this is basically z-axis. Keep that thing in your mind. Understand? This is how we are supposed to prove this one. Understand? Listen to me very carefully. How can I exactly prove this one? Now you tell me one thing. If I take, for example, a small mass over here, this is a very small mass over here, okay? dm, infinitely small, okay? This is a dm. Understand? This is a very small mass. We are supposed to find the moment of inertia of this one about this axis, if I say, for example, okay? Or I am supposed to prove this one. Whatever you think, I'll definitely do it. Now, if I'm taking this small mass dm over here, if I ask you to tell me the moment of inertia of this dm mass about this x-axis, you'll say, sir, moment of inertia about an axis is basically I is equal to mr square, okay? That should be the perpendicular distance in that case, okay? Now, you'll say, sir, if this is a dm mass, how far is it from the moment axis of rotation? By this is axis, this is a mass, this is r. How far this mass is away from this axis of rotation? You'll say I is equal to, that is mr square. This is how we calculate the moment of inertia of these discrete masses. Understand? Continuous mass bodies ka I have told you previously. So this is mass m. How far this is away from this one? This is the perpendicular distance. Understand? Perpendicular to this axis. Now you tell me one thing over here. How far this is from this x-axis? Can I say, for example, this is y? By y, I'll call this as y. Okay, na? If this is in 3D, don't confuse yourself. This axis is basically something like this. This is in 3D. For example, this is a body over here. This is x-axis, this is y-axis, and this is z-axis. Okay, this is z-axis, perpendicular to this one. This is y-axis, this is x-axis, and this is z-axis. Understand? Keep that thing in your mind. If I say, for example, अगर ये x है, imagine for example this is something like this. This is y and this is for example x, okay? Imagine for example this is something like this. If I say for example I'm taking this mass over here, how far this is from the axis of rotation? By if I'm supposed to find the moment of inertia of this mass about this axis, what I'm supposed to take? I'm supposed to take the mass of this one, if I say that is m, and perpendicular distance. By perpendicular distance kaun si hai? You'll say that this one, sir. So this is the perpendicular distance. How far is it from the axis of rotation? Understand? Kitna dur hai ye from the axis of rotation? Am I supposed to take that one? You'll say, sir, yes, I'm supposed to take that one only. So how much is this? You'll say, sir, this will be exactly how much? You'll say for example, y. By iska yahan pe y hi loge na. How? This is y is equal to 1, 2, 3, 4. That's why I'm saying take this as y. Understand? So over here, can I say this is y? Now, if I ask you to tell me the moment of inertia of this mass about y-axis, you'll say, sir, in that case, I'll tell you that how far it is from the y-axis. If I'm supposed to find the moment of inertia about this y-axis, you'll say mass into this perpendicular distance. So iska square exactly. ठीक है ना? So you will say, sir, this distance in that case. How far? You'll say, sir, this is nothing but x is equal to 1, 2, 3. If I say, for example, it's x over here, so you'll say x. Understand? That's why I'm saying how far this is from the y-axis, that is nothing but x. कितना दूर y से है, that is x. कितना दूर x से है, that is y. Okay? You getting me what I'm trying to say? Come on, everybody, give me some signal if you're getting me. Okay. Now see, this is exactly over here, okay? This is exactly over here. This is the DM mass, understand? So how far this is from this one? You'll say, sir, how far this is from? If I say, for example, this is, I'll just try to make it this one. See, this is the y-axis, understand? This is in 3D. That's why I'm not able to make it properly. It's something like this. This is y-axis, this x-axis, and this is z-axis. So I would say that. And if I ask you how far this is from the z-axis, you will say in that case, isko tum log aise banao. This will be, for example, this is r, okay? Very simple, understand? X-axis, y-axis, and z-axis. How far this is from that one? You call this as r. If you're taking this point, this one, understand? It's perpendicular distance you are supposed to take. This, something like this, understand? Keep this thing in your mind. This is a body exactly over here, understand? X se kitna dur hai, y se kitna dur hai, and how far this is from the z-axis, that is perpendicular to this one. This will also be perpendicular because this is in 3D, okay? Now, can you tell me the moment of inertia about x-axis? You will say, sir, because of this small mass, this is dm, the moment of inertia will be very small, that is di. So can I simply say, that will be, sir, that is dix, moment of inertia, small moment of inertia about x. That will be nothing but, say, sir, that is nothing but, this is dm, and how far this is from the x-axis, that is y. That is y square. That's why I'm writing this y, okay? I hope no confusion is in your mind. And if I just say the moment of inertia about y-axis, you'll say, sir, that is dm, and how far is it from the y-axis? That is nothing but x. This is x square. And moment of inertia about this z-axis, you'll say, sir, diz is nothing but dm, and that is r square. Why r square? Because how far is it away from this one, okay? This is how moment of inertia I is equal to mr square, okay? We can consider this as a discrete mass because this is infinitely small. In case of the continuous bodies, we're using the same concept, understand? Now, can I say in this case, this r square is nothing but that is x square plus this y square. This is a triangle. If you take this, x square plus y square will be exactly this r square over here. Now, from that, I can simply say diz is nothing but, this diz is nothing but, that is this dm. Instead of this r square, I can simply say this is nothing but x square plus this y square. Can I simply say it like that? 100%. Just multiply it. So diz will be exactly nothing but, this is a dm. Can I just say this will be x square plus this is a dm. This will be exactly y square. No confusion in this one. Everything clear? Fine. So what is this dmx square? Can you just tell me what is this dmx square? Dmx square is nothing but that is diy. So diz is nothing but that is diy plus this is dix. Dmy square is nothing but dix. Now, this is the small moment of inertia about z-axis of this mass. This is the small moment of inertia of this dm mass about y-axis. And this is the small moment of inertia of this small mass about x-axis. Now, if you want to find the total moment of inertia, in that case, you will integrate. So, you'll integrate it, integrate it, integrate it. So, after integrating, you'll get the total moment of inertia. We represent that by Iz about z-axis. Will be exactly equal to, this is nothing but Iy, plus will be exactly equal to, that is nothing but Ix. Just keep this in your box. This is the proof. Okay? Everybody got it, man? Okay? Next question we have this parallel axis theorem. What this is all about? Everybody, come on, I just want to know in this live chat over here. Come on. Okay. The moment of inertia of a body about an axis parallel to the body passing through its center of mass is equal to the moment of inertia of a body about an axis passing through the center of the product of the masses of the times okay. Whatever the stuff is basically written on the board, you can definitely read it out from yourself. So basically, this parallel axis theorem and perpendicular axis theorem helps us to find the moment of inertia about different axes. Okay, the rules and the protocols has to be followed. Understand? We need to follow that. Like this z-axis should be perpendicular to the plane and the other stuff as well that I told you. Now, in this case, listen to me very carefully what it exactly says. If I say, for example, there's a body over here, understand? This is a body, arbitrary body over here. Fine. Now, I'm saying over here that is nothing but this is the moment of, this is the axis which is passing through its center of mass. Okay. That axis which is passing through its center of mass, a body hai. This is the axis which is passing through its center of mass. Fine. Now, if there is another axis which is parallel to this axis, okay, this is a body. One axis which is passing through its center of mass, that is this one, okay? And there is another axis which is basically parallel to this axis. I'll just try to make it somewhere around here. And if I say, for example, that is at, for example, D distance from this one. This is at D distance from this one. Such that this distance is basically perpendicular distance. Keep whatever I'm trying to say, whatever I'm saying over here, keep that thing in your mind, okay? Focus on that completely. This is an axis which is passing through its center of mass. Ye ho gaya, this is a point number 1. Next, and there is another axis which is parallel to this axis, and distance between these two is basically D, and this is the perpendicular distance. Okay, you can clearly check this is the perpendicular distance between the two. Okay, if I ask you to tell me the moment of inertia about this axis, can you tell me about this axis? I say, for example, this is I dash. Moment of inertia about this is basically I dash. Moment of inertia about this is basically I dash. And moment of inertia about is nothing but that is ICOM. By iske about, the moment of inertia about this axis will be obviously ICOM because this is passing through its center of mass. So the moment of inertia about an axis which is passing through its center of mass is nothing but ICOM. And if I ask you to tell me the moment of inertia about this axis, say, sir, I have a formula. This perpendicular axis theorem tells us, I'll give you the formula. If you are supposed to find the moment of inertia about this axis, understand? This is telling us the formula. ये बोल रहा है मैं तुम लोग को दूंगा एक ऐसा formula जो तुम्हें बताएगा moment of inertia about this axis, which is, but the conditions are there that this axis should pass through the center of mass. Understand? पहले बताओ देखिए. Let's basically check what is that formula exactly. We say moment of inertia about this axis I dash is nothing but moment of inertia about center of mass plus m mass of this one plus m multiplied by that is a d square, this perpendicular distance ka square. So this is what we call the parallel axis theorem. Means this parallel axis theorem says that if you know the moment of inertia about an axis which is passing through its center of mass, fine, point number 1. And if you are supposed to find the moment of inertia about an axis which is parallel to this axis which is going through center of mass, and this perpendicular distance between the two is given, that is this d, you can easily find the moment of inertia about this axis, that is this one, ICOM Find the moment of inertia about this one, put it over here. Mass of this disk, mass of this body, put it over here. D square, this is the D, just put it over here, done. This is exactly the what? That is parallel axis theorem. That's why we say, because these two lines should be exactly parallel. Keep that thing in your mind. This line, which is exactly parallel to this one, this should be exactly parallel to this one. Understand? This distance should be perpendicular distance. This should pass through the center of mass. Understand? We say basically in this case, two axes should be parallel to each other. Point number 2 is D should be perpendicular distance. Point number 3 exactly in that case is basically, what is this? This और क्या था? And ICOM, obviously that should pass through, obviously that is passing, should pass through, or one of its axes should pass through center of mass, whatever it is, okay? Keep that thing in your mind. This axis should pass through the center of mass. Now, if you want the proof of this one, let me just give you the proof of this one. Come on, I just want to know in the live chat if you guys understood this one. Understand? I just want to know if you guys understood this one. Come on, everybody over here. Did you guys understood this one? Drop a crystal clear. Come on, I'm just waiting, man. Okay, let me just give you the proof. Okay, I'm saying, for example, this is an axis which is passing through its center of mass, and this is another axis. This is C. This is an axis about which I'm supposed to find the moment of inertia. About this axis, ये हो गया ये वाला, ठीक है? We are supposed to find the moment of inertia about this axis. Understand? Keep that thing in your mind. Listen to me very carefully. Can I say the moment of inertia about this axis will be, I call that ICOM, okay? Moment of inertia we represent with I. Moment of inertia about an axis which is passing through its center of mass is nothing but ICOM. The distance between these two is, for example, this is D, okay? And what we are supposed to prove, that is nothing but I is equal to ICOM plus MD square, okay? So we say moment of inertia about this axis is nothing but I dash. We are supposed to find this moment of inertia, understand? Now you just tell me one thing. I'll use the same concept that I used previously. If I say, for example, I'm taking the small mass over here, for example, okay? And this mass is exactly at, I say, for example, at A distance over here, or R distance, okay? This is at R distance. Now, if I ask you to tell me, this is the small mass, that is dm. If I ask you to tell me the moment of inertia because of this small mass about this axis, sir, it is very simple. Mass over here about this axis, I is equal to mr square. So this is a very small mass, so the moment of inertia will be very small. So we say that is nothing but di. So di is nothing but that is dmr square. So we say dm, and this will be exactly r square. And can I say this is com? So I can say this is com, because moment of inertia about an axis which is passing through its center of mass. So dicom is equal to dmr square. Point number 1. Now, if I ask you to tell me the moment of inertia about this axis over here, this is the axis. You'll say, sir, it is very simple. I can find it over here in this case. Let's say, sir, this is a di, that will be very small. This is a di dash. If I say this is I dash, will be nothing but that is, they will say, sir, this is a dm, and this perpendicular distance, that is d plus this r, its square. This is a d, this is this d plus this r, its square, exactly. I can simply say it like that, okay? No confusion till here. So this one. Now, if I ask you to basically isko khol do, theek hai? So can I just simply say this will be, isko idhar likhta hu, I'll just write it over here. Can I just write this as, this is di dash, theek hai na? I'll just write it as di dash, okay? So this will be exactly equal to, in that case, you'll say, sir, this will be exactly, that is a dm. First, this will be this d square exactly. Can I just say it like that? dm into this d square. So dm into this d square. Ab isko d mat rakho. This will confuse you over here. Write it basically x. Not a problem, but this is bit confusing over here. That's why. So dm into this x square. This is x square. तो इसको भी हटाता हूं. I'll just change it over here. this will be exactly, this is x. Yeah, one and the same thing. You can put the d as well. Understand? अब यहाँ पे same हो रहा था, थोड़ा सा दिमाग सर क्या हो रहा है, that's why. So this is dm into x square, okay? And this will be, this is x plus r whole square. So can I say basically this will be exactly plus, this is a dm, then it will be this r square. I can simply say it like that, 100%. And then what exactly I'm gonna write? You'll say, sir, this will be plus, that is 2 xr, and this will be 2xr exactly, and this will be exactly dm in that case. ठीक है ना, इसको खोल दिया, that's why I'm writing it something like this over here. So this is what exactly we got over here. Now if I ask you to basically integrate this one, understand, you'll say, sir, integration will get the total net moment of inertia in that case. So integrate, understand? So what exactly you'll get? You'll say, sir, this is I dash, integration of this di dash, that will give me, that is nothing but this I dash. So over here, dm into x square. Can you just tell me what is this dm into x square over here, and what is this dm into this r square over here? Okay, you'll say, sir, this dm into r square, I can simply represent it with this one over here. Understand? Now this dm into this r square, I can simply say that is nothing but kya? That is di, ye ho gaya na, dicom. Understand? When I integrate that dicom, I can simply write it, that is nothing but what? icom. अरे समझ आया, एक step I'm basically cancelling. I cancelled one step, one of the steps. Okay, see, this dm into r square is nothing but dicom. When you put dicom over here, you'll say, sir, integration of dicom, that is small moment of inertia, integration of that small moment of inertia about this, I'm talking about this axis. You'll get the total moment of inertia about the center of mass, that's ICOM. Ab bacha ye plus. What about this one? dm into this x square, integration of dm into this x square over here. You'll say, sir, integration of this dm into this x square over here, this is the distance x between this and this. So if I just take this out, so integration of this dm will be what? If you integrate this dm, you'll get the total mass of this one. A small masses ko jab add karoge, when you add these infinitely small dms, you'll get the total mass. Understand? So in that case, this will be m, and this is x square. Can I just say it like that? This was a d, ठीक है ना? D को x को हमने d को हमने x कर दिया. So this will be mx square in that case. And we say plus. We basically put this quantity exactly as equal to 0. Why do we put this quantity exactly as equal to 0? Because there is a reason behind that. There is a reason behind that. Let me just tell you what is that. अब सुनो, इसको 0 put करता हूँ. We say basically I dash is equal to ICOM plus this mx square. I'll tell you the reason. Okay. This is the proof. अब x को मैंने यहाँ पे previously it was md square because I took d over here. One and the same thing. इसका नाम d रख दो, फिर से d डाल दो. It's one and the same thing. Understand? This is the proof of this one. This is the moment of inertia about this axis. If you know the moment of inertia about an axis which is passing through its center of mass, and these two axes should be parallel to each other, this distance should be the perpendicular distance between the two axes. Keep these things in your mind. Okay. Okay. Good to see you too. Pragya, good to see you too. What's up? How are you doing? Okay, so that's what we exactly got over here. Fine. I hope you got it. Now listen to me very carefully. Why did I basically take this one as this one? Now, if I say, for example, I'll just write it over here. This is 2x rdm integration. Now, can we just write it, for example, something like this? I'll take this 2x exactly out. Eh, bhai, ye hai na, ye x hai. This was exactly x constant over here. Ye wale distance. Isko bahar le lo. Can I just write this will be rdm in that case over here? Understand? 100% you can say this is rdm. You tell me one thing. If I say this is 2x and multiply with m, capital M, mass of this entire body, and this will, and divide by the m. So you'll say integration of this is this is dm upon this m exactly. Listen to me very carefully. Can you just tell me what is this? You'll say, sir, this integration of this rdm divided by this total mass m. You'll say, sir, this is nothing but rcom. This is nothing but rcom. That is coordinates of the center of mass in a continuous body. अरे उस वाले में क्या हम करते थे? That is m1 r1 plus m2 r2. Understand? If we have different number of discrete masses, in that case, if we were supposed to find the coordinate of a center of mass, In that case, we were basically using M1 R1 plus M2 R2 plus M3 R3 upon total mass M. Understand? So you will say over here, in case of a discrete body, what we exactly say, this RCOM is nothing but that is this one. That is integration of this R, this dm upon this m exactly. Now you just tell me one thing. What is this R? You are measuring this R, basically you are measuring this R from the center of mass itself, because you are measuring this R about from the axis which is passing through the center of mass itself. Understand? So can I say in this case, coordinates of the center of mass is exactly 0, 0. Yeah, this axis is exactly passing through the center of mass. I hope you're getting me what I'm trying to say. Okay, this coordinate is exactly, this axis is exactly going through the center of mass only. Understand? So can we say in this case, coordinate of the center of mass is exactly 0, 0? That will be exactly 0 in this case. Can we say something like that? So that will be 0 in this case, because we are measuring this distance from the center of mass itself, from this axis itself. So this will be exactly in this case 0. By kahin aur se hota, then it is something else. To hota kuch. Lekin in this particular case, this axis, in case of parallel axis theorem, one of the axis is passing through the center of mass. So we say that is 0. That's why, because the coordinates of the center of mass over here is basically 0. So we are taking basically that equal to 0. That's why if you multiply this m over here divided by this m, this will become 0, because in this case, understand, that's why we're taking this as 0. I hope you got the feel of this one. Okay. Thank you so much, sir. Thank you, sir. Great. Now to okay. That's great. That's great. Good luck. Go for it. Okay. Now, people. Okay. Okay. Let me just give you one more question exactly over here. Kahan pe de do? Chalo, idhar de dau. If I say, for example, over here, I have a question exactly. That is nothing but I have, for example, a disk. Okay, this is a disk. Fine. Can you tell me if this is an axis which is, for example, touching this exactly over here? Ye isko touch kar raha hai. This is a tangent, something like. Understand? This one. Okay, this is a disk. This is a tangent to the disk. It is not something like this. Understand? And you are supposed to tell me the moment of inertia about this axis. Okay, I dash. How much this will be? This is a disk. Understand? This is a disk. Tell me how much is the moment of inertia about this axis which is touching it. Understand? Tangent hai. Okay? About this axis. How can you? Here, we'll have to use both perpendicular axis theorem as well as parallel axis theorem. Understand? You just tell me one thing. If we are supposed to use the parallel axis theorem in that over here, then parallel axis theorem says I dash is equal to about this axis, that is ICOM plus MD square. Okay. If you want to find the moment of inertia about this axis, then you should know, then you should have the information about the moment of inertia about an axis which is passing through its center of mass. Understand? And that should be parallel to this one. So it should be something like this. Understand? But ye disk aise, this is one axis, this is the another axis which is passing through its center of mass, such that you know the perpendicular distance between these two. Okay. If I say, for example, that is R over here, radius of the disk over here, this is a tangent, this is that tangent. Okay. So can you tell me the moment of inertia about this disk, about this axis? By this is not the axis which is perpendicular to the disk and passing through its center of mass. No, about that we know mr square by 2. This is the disk which is passing through its center of mass but is lying in its plane. Kaise nikale? First of all, we need to basically use the what? That is parallel axis theorem. Understand? Perpendicular axis theorem. Let's see how we can exactly solve this one. We are supposed to find the moment of inertia about this axis. Understand? Now, if I say, for example, I am supposed to find the moment of inertia about this axis, it is something like this IY. Okay. If I am taking, for example, another axis, I call this as IX. The moment of inertia about this IY will be exactly equal to the moment of inertia about this IX. Previously, I told you this is symmetric. Okay. Disk is symmetric. From all the sides, it will look same. So we say this is the another axis, that is nothing but IZ. So we know moment of inertia about this Z axis. So how much that is mr. Arey bhai, use karna pehle directly. Just use it directly. You'll say, sir, this IZ is nothing but this is IY plus this IX. IX is equal to IY in this case, and this is how much? We'll say, sir, this is nothing but mr square by 2 in case of a disk. Moment of inertia about an axis which is passing through its center of mass and is perpendicular to the disk. So we say is equal to nothing but this is twice Ix. So Ix is coming out to be nothing but mr square by this 4. क्या मैं ऐसे लिख सकता हूं इसको? 100% I can simply write it like that. Now I got the moment of inertia about this axis. Fine. About this axis Iy के about निकाला था ना, चलो इसको twice Iy कर दो. It's one and the same thing. Twice Iy, because moment of inertia about this axis is equal to moment of inertia about this axis. So you got the moment of inertia about this axis exactly. How much is that? I is equal to, I for example say Iy or ICOM. This is also COM. Why? Because this is passing through the center of mass. Understand? Now you will say, sir, why cannot I take this axis and this axis? Because the condition in parallel axis theorem is the two axes should be parallel to each other. This axis and this axis are not parallel to each other. Understand? So this axis and this axis are exactly. So that's why. So we say ICOM in this case, kitna aaya? We'll say mr square by 4. Now use the parallel axis theorem. You'll say, sir, that will be nothing but I dash I'm supposed to find. This will be exactly ICOM mr square by 4. This is mr square by this 4 plus. You'll say, sir, md square. How much is this d? That is nothing but r. Say, sir, that is nothing but mr square. Understand? This perpendicular distance between the two axes. Kitna hoga? 4 mr square plus mr square, 5 mr square by 4. Very simple. Understand? I hope you got it, man. Thank you so much, ladies and gentlemen. This was all about today. Okay. This was all about today. Now, rest we'll be talking about some of the previous year questions of mains and advance by today itself. Okay. Tomorrow itself. Sir, I feel like I'm in 9th, 10th studying basics of physics, chemistry and SST also for NDA. Okay, that's great. Okay, when is your NDA exactly? It's on 14th of November. Okay, that's great. That's great. So you want to go in defense. So now people, we have this Telegram channel link, understand? You can definitely join our Telegram channel as soon as possible, because whatever the important stuff we have, we send it in our Telegram channel only. Understand? So join it as soon as possible. Okay. Join ASAP. Okay. Because whatever the notes we send, whatever the important news is, we put up over there only. Now the next point exactly is that is nothing but if you people want to take your rank to the next level, if you people want to learn from the top educators of the country, you are supposed to join this plus and you are supposed to join this Iconic, because you might have recently seen that Unacademy has produced so good results. Okay. So good results in JEE Mains and Advance 2021. Okay. We have produced AIR 1 was from Unacademy. 87 was from Unacademy. You people wanna take your rank to the next level like those people have done, join this plus and Iconic. Okay. What are the benefits that you can exactly get? Live classes every single day from the top educators of the country. Weekly tests every single day. Structured courses, the courses which have been designed by the top educators, those experts who have got 20 to 30 years of experience. Okay. Okay. And unlimited access, obviously. Okay. And in this Iconic subscription, okay, if you take this Iconic subscription, you will be getting personal guidance. That is nothing but personal mentorship. Okay. This personal mentorship is all about, you will be getting a guide, personal guide. If you need any sort of clarifications, you can definitely ask him. Okay. Okay. And this test analysis as well. Test analysis is basically done from our end only. You just don't have to do anything. You just have to focus on your studies only. Okay. So that you will get the better scores in your upcoming time. Okay. And this experts guidelines. Okay. Whatever the important guidelines you are supposed to follow in order to crack JEE Advance, those will be given to you. Study material. That material will be sent to you to your doorstep so that you'll get the bookish feel. You don't have to learn from the PDFs anymore. Next is, ladies and gentlemen, for how much amount of time you can take this Plus and Iconic. You can take it for 24 months, 18 months, 12 months, 6 months, 3 months, okay? By using my code Yawar, you can get the maximum possible discount. So for 24 months, 18 months, 12 months, 6 months, use my code Yawar to get the maximum possible discount. These are the basically what we say, these are the features that you can exactly get. These are the features that you can exactly get. Now, if you find any of my content as inappropriate, link is in the description below, report over there. Okay, so thank you so much, ladies and gentlemen, boys and girls. Hit the subscribe button. Thank you so much, ladies and gentlemen. Hit the subscribe button. Okay, Pragya, take care. Bye-bye. Yes, okay, that's great. Good luck. So subscribe to the channel and hit the bell notification. Till then, bye-bye. Take care. See you guys.